Okay, we're picking up where the video left off, and if you will go to the first page of the notes for 3B on page 8, this is the last example that was worked, and it turned out that there were an infinite number of solutions. Remember that in Algebra 2 we're going to go one step further, and we're going to write what's called a general solution as an ordered pair, and that ordered pair will have x in the x-coordinate position and then 2 minus 3x in the y position. That 2 minus 3x came from what y is equal to. So all the solutions have to fall into the pattern of that general solution. If we pick an x value, we can calculate the y value by subtracting 3 times the x value from 2. All right, in example 2, we're going to solve a few more systems by substitution. And remember, you can follow that 2-column approach to keep things organized. We have negative x plus 3y is equal to negative 1 is one of our equations, and the other is x is equal to negative 2y plus 4. When we do the substitution method, the first thing we have to ask ourselves is it possible to solve one of the equations for one of the variables? And if you look at the second equation here, this is already solved for x, so I'm simply going to take this equation and I'm going to replace the x in the first equation with that expression. So the opposite of the x value plus 3y is equal to negative 1, and the x value is negative 2y plus 4. You notice what happened. Now we only have the variable y in the equation. So distribute the multiplication by negative 1. That's positive 2y minus 4 plus 3y is equal to negative 1. And combine like terms, 5y minus 4 is equal to negative 1. Adding 4 and then dividing by 3, or rather dividing by 5, we get 3/5 for y. And we're going to take that and go back into the other column and figure out what the x value is. X is equal to negative 2 times the y value plus 4. And now we know that the y value is 3/5. So negative 2 times 3/5 is negative 6/5. And we need to add 4 to it, so we need a common denominator. 20 divided by 5 is the same as 4. So that gives us a common denominator of 5, and x is equal to 14/5. So make sure to write your answer in ordered pair form, which means x comma y with parentheses around it. And there's the solution to the system. Let's try another. X plus 2y is equal to negative 3, and 3x plus 6y is equal to 9. I'm going to use that 2-column approach again. And our first equation is x plus 2y is equal to negative 3. And second is 3x plus 6y is equal to 9. And the first equation can easily be solved for x by subtracting 2y from both sides. And then we can take that and replace x in the second equation with that expression. So 3 times the x value plus 6y is equal to 9. And we're replacing x with negative 2y minus 3. Now let's distribute the multiplication over the subtraction in the parentheses. Negative 6y minus 9 plus 6y is equal to 9. And simplifying the left side of the equation, that gives us negative 9. And equals 9 on the right side. That's never true, which means that there is no solution to this system. If we wrote each of these equations in y equals mx plus b form, these two linear equations would have the same slope and different y-intercepts, which is going to make them parallel. All right, now let's take a look at one last example. This one looks a little bit different. So I'm going to use my 2-column approach. Y is equal to 1/2 times x minus 4. And in my second column, y is equal to negative 2/3 times x plus 3. if we're thinking about how to solve this using substitution, both equations are already solved for y, so I'm simply going to take one equation and replace the y in the second equation with what y equals in the first equation. Now we do get a fractional coefficient equation, but that's easy enough to remedy. We can multiply through by the least common denominator by 6. So 1/2 x times 6 is 3x. 4 times 6 is 24. Negative 2/3 x times 6 is negative 4x. And 3 times 6 is 18. Adding 4x to both sides. And then adding 24 to both sides gives us 7x is equal to 42. And then dividing by 7, x is equal to 6. We can take that information and go back to the first column. And the y value is equal to 1/2 times the x value minus 4. And now we know that x is 6. So that's y equals 3 minus 4 is -1. Make sure to write your solution in ordered pair form, 6, -1, x, y, with parentheses around it. All right, in the video notes, you did the first 2 examples for linear combination, so we're going to pick up with example 4. And you might notice this is a very good one to work with elimination because it's very problematic, I think. It's not impossible, but it's problematic to solve each equation for x or for y, since none of them have a 1 coefficient. All right, so I'm going to think in terms of least common multiple. So if I want to eliminate the x's, I need to think in terms of the least common multiple of 3 and 4, which is 12. Or if I wanted to eliminate the y's, I need to think in terms of the least common multiple of 5 and 3 is 15. So in order to give the x's the same coefficient, I'll just pick the x's. You can do it either way. I'm going to multiply the first equation by 4, which will give us that 12x minus 20y is equal to 44. And then multiply the second equation by -3, which will give us -12 times x plus 9y is equal to -33. So now you'll notice that we got 2 equations where the x coefficients are opposites, and we're going to add them together so that our opposites add up to 0. So 0 minus 11y is equal to 11, or just -11y is equal to 11. Dividing by -11, y is -1. And now we can get the value of x by substituting into either of the 2 equations. So let's just pick, for instance, this first equation. And if we substitute into it, we get 3x minus 5 times -1 equals 11, or 3x plus 5 is equal to 11. Subtracting 5 from both sides and dividing by 3, x is 2. And so our solution in ordered pair form is the 0.2, -1. Make sure to use parentheses around your ordered pair. Now let's look at B. And in B, we'll notice that you have fractional coefficients here. So in order to eliminate the fractional coefficients, we can just take each equation and multiply by the least common denominator in each equation. So the least common denominator for the first equation is 6. Multiplying through by 6, we get 2x minus y is equal to 3. And we'll worry about eliminating the variable later, right? But we want to just eliminate the fractions first. Multiply the second equation by 4, and that will give us 2x plus y is equal to 1. And now you'll notice that the y coefficients are already opposites, so I'm just going to add the 2 equations together and get 4x is equal to 4. Dividing by 4, x is 1. And now you can substitute into any of the equations to find the value of y. My suggestion would be one of the ones without fractional coefficients and the one where the y variable has a positive coefficient. So 2 times the x value plus y is equal to 1, or 2 plus y is equal to 1, and subtracting 2, y is negative 1. So the point 1 comma negative 1 is the ordered pair solution. We have one example left to do, and that example is a system in which we have some decimal coefficients. Now remember, decimals are really just like fractions. The place right after the decimal point on the right of it is called the tenths place, and the next place is called the hundredths place. So the least common denominator of these two fractions is really 100. Well, that is a common denominator is what I should say. It's not the least common denominator, but it's something that we can easily use. So I'm going to clear the fraction here by multiplying by 100. And remember that when we multiply by 100, we just scoot the decimal over. So that gives us 30a plus 15 times b is equal to 1200. And now if I want to, for instance, eliminate the b's, I can multiply through by negative 15 for the first equation, and that'll give us negative 15 times a minus 15 times b is equal to negative 900. And adding the two equations together, we get 15 times a is equal to 300. And now dividing by 15, 15 goes into 30 twice, so into 300 20 times. And now let's pick the easiest equation to sub into to find b, which would be this one right here. That's the simplest form that we've got. So a is 20 plus b is equal to 60, and that'll give us a b value of 40. Now, of course, they're not x's and y's, but we can still put them in ordered pair form. Typically, we're going to do that in a comma b form. So when you have two variables, they're typically in alpha order. You'll probably only ever see x comma y and a comma b as far as that's concerned. So you don't have to sing the alphabet song. And that's it.